S1. Minor solar radiation storm. Minor S1. Solar radiation storms occur often during the solar cycle. Storms create little disruption at this level. Near the poles, high-frequency radio waves may degrade slightly. Satellite operators may observe increased noise or single-event satellite electronics upsets. Commercial airlines flying over polar regions may make minor route alterations without endangering public safety. Scientists and space agencies follow these storms without public involvement. S2. Moderate solar radiation storm. At S2, solar radiation storms are more evident, especially for the satellite and aviation industries. High-altitude pilots in the polar regions may have to change their plans to avoid radiation. Satellites may have small hardware or memory failures, and astronauts on space stations should stay in shielded regions. Small faults in navigation and communication systems may not create large problems. These catastrophes are still common, but affected areas must prepare. S3. Strong solar radiation storm. S3 level solar radiation storms are categorized as strong and can have significant consequences. These storms can severely affect satellite operations, often requiring protective shutdowns to avoid damage. Radiation levels may be high enough to expose astronauts in space to unsafe doses, requiring immediate protective measures. Commercial aircraft may avoid flying over the poles entirely during these events. Navigation systems can be disrupted, and communication signals may be degraded or lost in high-latitude regions. This level of storm occurs less frequently but is taken very seriously due to the growing dependence on space-based technology. S4. Severe solar radiation storm. An S4 storm is severe and considered a high-risk event for satellites, astronauts, and even aviation on Earth. Space agencies often halt spacewalks, and astronauts must retreat to radiation-shielded areas of spacecraft. The likelihood of satellite damage rises sharply, and critical electronic components can malfunction. For airlines, especially those flying transpolar routes, flight paths are drastically altered or flights are canceled to prevent excessive radiation exposure to passengers and crew. Ground-level impacts may include disrupted GPS and communication signals. This level of solar radiation storm is rare and can cause millions in damage. S5. Extreme solar radiation storm. The S5 level is the most extreme and rarest type of solar radiation storm. These storms pose a serious threat to astronauts, even inside spacecraft, due to dangerously high radiation exposure. Satellite systems may be rendered useless or suffer irreversible hardware failures. High-frequency radio signals and GPS systems can become completely unreliable for hours or even days, especially in the polar regions. For commercial aviation, no flights over polar routes are considered safe during an S5 storm. These storms could also induce harmful electrical currents in pipelines and ground-based systems, causing unexpected damage to infrastructure. R1. Minor radio blackout. An R1 level radio blackout is considered minor and usually results from small solar flares. These events can cause weak or brief fading of high-frequency radio signals, especially on the sunlit side of Earth. Pilots and maritime operators using HF communication may notice temporary signal loss. However, these effects are short-lived and rarely cause any lasting damage or disruption. Navigation systems like GPS might experience minor inaccuracies, but overall, public safety remains unaffected. These blackouts occur frequently and are typically only of concern to certain professionals. R2. Moderate radio blackout. A moderate R2 radio blackout can cause limited disruption to communication and navigation systems. High-frequency radio signals on the sunlit side of the Earth may experience degradation for up to several minutes. Communication issues may arise for aircraft or ships operating in high-latitude regions. Additionally, GPS accuracy can be compromised, especially for real-time applications. These events are still relatively manageable but require caution for those relying on continuous, accurate radio or satellite communication. R3. Strong radio blackout. When a solar flare reaches the R3 level, it can cause strong radio blackouts with noticeable effects. High-frequency radio communication on the sunlit side of the planet may be completely blacked out for up to an hour or longer. This level of disruption can severely affect emergency response teams, aviation operations, and maritime communication. GPS errors increase significantly, especially in precise navigation systems used by airlines or military forces. These events are tracked in real time by space weather agencies to issue alerts and mitigate their impact. R4 Severe Radio Blackout. A catastrophic R4 radio blackout can damage most of Earth's communication infrastructure. Daytime high-frequency radio contact can be lost for hours over wide distances. Even airplane and ship emergency frequencies may be unavailable, posing a safety risk. GPS and other satellite navigation aids can experience widespread malfunctions or shutdowns. Avoiding dangerous situations may require aviation traffic control to divert or delay flights. These unusual instances might be dangerous, especially during global conflict or disaster response. R5. Extreme Radio Blackout. The R5 level represents the most extreme form of radio blackout caused by massive solar flares. Communication via high-frequency radio can be completely shut down across the sunlit half of the Earth for many hours. Satellite operations, navigation systems, radar, and even military-grade communication tools can fail. In such events, there may be widespread confusion due to the sudden loss of communication channels. Emergency services and aviation are deeply affected. Fortunately, R5 blackouts are extremely rare and are the subject of intense scientific monitoring and early warning systems. G1. Minor geomagnetic storm. A G1 geomagnetic storm is the mildest category of geomagnetic disturbance. At this level, power systems may experience minor voltage fluctuations, and satellite operations may require slight corrections. Some spacecraft might encounter increased drag due to the expansion of Earth's upper atmosphere. Interestingly, auroras, northern or southern lights, can become visible in areas where they're normally not seen, like parts of Canada and northern U.S. states. G1 storms are common and not usually cause for alarm, though they can occasionally interfere with sensitive equipment. G2. Moderate geomagnetic storm. G2 storms are stronger and can impact power systems by triggering voltage alarms or causing transformer noise. Spacecraft can experience orientation and tracking issues due to increased atmospheric drag and magnetic interference. In addition, auroras can be seen at lower latitudes than usual, reaching areas like New York and Idaho. Navigation systems and amateur radio operators may experience brief interference. These storms are more noticeable but generally manageable with the current infrastructure. G3. Strong geomagnetic storm. When the storm reaches G3, it becomes strong enough to cause significant interference with electrical grids and satellite functions. Power companies might need to take protective actions to prevent grid failures. Satellites in low Earth orbit could experience drag strong enough to alter their paths or shorten their lifespans. Radio signals and GPS accuracy may degrade for several hours. Meanwhile, auroras can be visible as far south as Illinois or Oregon. At this level, power grid operators and aerospace agencies pay close attention to incoming solar data. G4. Severe geomagnetic storm. G4 storms are severe and pose a major threat to global infrastructure. Voltage control problems can occur in power grids, and protective systems may shut down equipment to prevent permanent damage. Satellites may be rendered temporarily useless or even fail. GPS, communications, and military radar systems can be severely impacted. Auroras become visible in much of the continental U.S., including southern states like Alabama. The storm can last for hours or even days and may disrupt financial, transportation, and communication systems globally. G5. Extreme geomagnetic storm. Extreme G5 storms can cause devastating damage. These occurrences can destroy transformers and cause massive power outages, like the 1989 Quebec blackout. Satellites may fail catastrophically. GPS, radio, and ground-based communication may fail. Storms can influence the entire planet, and auroras may appear in Florida or Texas. The 1859 Carrington event, which disrupted global telegraphs, was the most famous G5 storm. A similar storm now may cost trillions. If you found this video eye-opening, make sure to hit the like button, subscribe, and ring the bell for more science breakdowns and cosmic curiosities. And let us know in the comments, do you think we're prepared for the next big solar storm?